Hello and welcome to episode 106 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again, and welcome back, Amalith.
It's good to be back.
A couple of episodes ago, we talked about refactoring code. But one thing we didn't talk about is just chucking it out the window and starting all over again, rewrites. I get the feeling, Andy, that you are not one for doing rewrites.
Yeah, so back in 2000, before most of you were born, I read an article by Joel Spolsky called Things You Should Never Do, Part 1, in which he discussed at length the decision by Mozilla to rewrite the Mozilla browser before Firefox existed, this was. And Mozilla had open sourced their proprietary browser, or Netscape rather, had open sourced their proprietary browser and called it Mozilla. And the community had looked at it for a while and thought, oh, this is awful. We need to throw it all out and rewrite it from scratch. And this article by Joel Spolsky, a blogger, because we had these things called blogs back then.
We do again now. It's come full circle.
Yeah, apparently we've got them back, yeah. And this article by Joel Spolsky basically argued that the rewrite was a massive waste of time. And during that time, Internet Explorer, the famous superior browser, had taken over the internet because the community had decided to throw out all this working code and rewrite it from scratch. He makes a really strong argument in there, which I still basically agree with, which is old nasty code is basically code that's full of bug fixes and workarounds for stuff that you've forgotten even existed. And all that crusty stuff, not all, but a lot of that crusty stuff is stuff you really need. And if you write it all again from scratch, you're going to just end up with all the same bugs plus a load of new bugs. You'll be fixing all those bugs for years when you could have been building on the foundation that you already had. And you only hate it because you're lazy, essentially. You should take the time to understand it.
You can really tell that this is from the year 2000, this blog post, because there's an image of like an apartment building or whatever, and it's got a drop shadow on it. And so I opened it in a new tab, and sure enough, it's not CSS or anything. It's on the image itself. So do you agree with this thesis then?
I basically agree with it. So I've worked on a number of projects where someone somewhere had decided that the best thing to do was write the whole thing again from scratch. And the times we were successful was actually when we ended up going back to the old thing we'd left behind, fully understanding it, and either reintegrating it back into what we were doing or implementing all that knowledge that was contained in the old system into the new system. So there are times when you just have to rewrite maybe because you're changing to a different technology. But, I really think you should avoid it.
Oddly enough, Andy, as well, I also agree that rewrites should be, I won't say rare, but you should take a lot of care in deciding when and why you're going to rewrite something. I mean, all of us love to rewrite something. That's I hear it super often. Let's go ahead and rewrite it. But you should really understand why you're undertaking that massive undertaking to rewrite something. So although I think, there's the meme out there, rewrite everything in Rust, and both me and you are big fans of Rust. Yeah. However, I think both of us are also very, very cautious about when to rewrite stuff, and that you have to have a really good reason as to why you're going down that path.
Amalith, your friend had some questions about this.
Yes, basically when and what should I refactor? They found that most issues with old code are usually leaving a lot of dead and complex code around, and refactoring often and aggressively doesn't leave that code base in a very stable state. So knowing what to rewrite and when is a hard question to tackle, they find.
I think also we should probably caveat that there are different types of rewrites as well. There is rewriting into a different language. There is rewriting in the same language. They're just using different frameworks, different paradigms. There's all kinds of different rewrites. So not to leave it at it depends kind of answer, but answering those types of questions will also determine what it is that you look for and what parts you want to rewrite or why. And I think in the question that your friend posed to us, one of the things that they mentioned was Chesterton's fence, which I don't remember exactly how it goes, but it's something along the lines of if you come up to a fence, don't remove it until you know why that fence was put there in the first place, which is a really good guiding principle when it comes to code as well. If you come to some code and you think it's dead code, it may not actually be dead code. You should have some way of verifying that code actually is dead code and actually never used under any of the edge cases that the code may run into.
Well, we got into this when we talked about refactoring, right? You have to understand what you're doing first. That has to be the first step.
I think we should be really careful about what we mean when we say refactor, right? So the word refactor, when I use it, has a very specific meaning, which is replacing code with code that does exactly the same thing but is differently structured, right? So you can't talk, if you're using refactor that way, you can't talk about rewriting in a different language or something like that as refactoring, right? That would be rewriting or replacing parts. And the reason why it's important, right? There's not just like a technical thing about what a word means. It's because refactoring is way safer than other types of modifying programs. If you do it right, if you understand how the code works and you have a way of checking how it works, preferably by running a load of tests, then you can refactor and safely know if all your tests pass that you haven't broken the code, but you have made it easier to understand. So refactoring is like the best type of rewriting, and all the other types are much more risky and harder.
And I think I often find with, I won't say a lot of times younger developers, but no, I would say that's probably who it comes from the most, is whenever you hear someone say that they want to rewrite, in my experience, it's been a lot of times because they don't understand what the code is doing, or they don't understand why a certain thing is written a certain way. And that's the reason I've heard given the most. I want to rewrite it because I don't understand it, and I want to rewrite something that I do understand. And I think that's actually the most dangerous version of a rewrite, because that's the one that leads to all of these. You're going to end up with way more bugs in the rewrite. You're going to end up retreading the exact same edge cases and bug paths that the old code has already found and fixed.
Yeah, and that's the reason why I'm so passionate about it, is because I'm really lazy. And so I'm constantly pulled by this desire to just throw it all out and rewrite it. And I have to say to myself, no, you can't be lazy. You've got to take the time to understand it.
Now, having said all that, I also do think that there are times where a rewrite or a massive refactor could be a benefit. And I think that's most often when, at least in my own experience, when one, the code is fully understood, but also you are shifting to some other type of paradigm or framework or language or whatever the case is, because you can take advantage of some of those newer offerings. So for example, if let's say in framework or language or paradigm A, you end up having to defensively code against a bunch of different patterns or things that could go wrong in the code, and then in language or paradigm B, those things are already inherently taken care of, either due to, let's say, a type system or a library or something along those lines. Those can be massively beneficial because they can simplify the code, or they can make the code easier to read, or they can catch the additional error cases that were not caught or had to be caught manually in previous code. But this is kind of by exception, and one of the, if someone is giving this reason, like some due diligence better be involved in determining whether or not this really is one of those cases.
You're basically saying rewrite it in Rust.
I was trying to, and I think people may have caught on to that, but...
Well, what about when the code was written in the wrong language? So say you've got some bash scripts, right? Or you've got one bash script that just gets completely out of hand. It starts as just a few commands and it just sprawls and sprawls and sprawls to the point where it's just taking like 2 or 3 seconds to run, where if you rewrote that in Rust or C or even Python, it would be much more efficient. Like, surely there's got to be equivalents to that with other languages.
I might say that going from a script to a, proper language, I guess procedural imperative.
You're saying that Bash is not a proper language?
Something that is not a scripting language.
Okay.
Might be a great example of when rewrites should happen often. If they're big scripts, of course.
I also think that's a good example, a really good example of how you can do it in small bits and avoid this massive throw it all out and replace it. So if you look at the way a tool like Git was constructed, a lot of that was written in Bash and then gradually replaced with C programs. And because it was deliberately structured so that you could, it was just programs that pipe things to each other, that was particularly easy. But with almost any complicated Bash script, you could probably replace it piece by piece with stuff written in a different language. And if there's any path to doing it in small chunks, instead of doing it in a great big whack, you should take that path. And that gives me an opportunity to correct something that I said in a previous podcast when I talked about the strangler pattern, which I think should be called the strangler fig pattern, thanks to Jez for pointing that out to me. That is a pattern where you surround the old code with a new surrounding layer of new stuff, and then as requests or things that need processing come in, your new code decides, is it going to hand off to the new code, or is it going to just give it over to the old code and let that process it? And then you can gradually, piece by piece, replace what you're doing with more and more of the new code and keep that old code gradually shriveling away in the corner. And it's just an excellent way of making a step-by-step replacement out of something that looks like it's going to be impossible, because your kind of ball of mud old code is hard to extract bits out of.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too, at linuxdevtime.com/support. I know that rewrite it in Rust is a proper meme at this point, but the reason that meme exists is because of the memory safety, right? Like, rewriting it in a different language that has a great feature that makes it more secure, surely that is a reasonable argument, isn't it?
I think that's a large part of it. There's a few additional benefits, which is why I think people get so fervent about it, is the memory safety is a big aspect. That yes, that is huge. But there's also a stronger type system. It's still a fully compiled language, so it's extremely fast and performant. So there's all these things that kind of benefit where people say like, oh, it would be really nice to be able to write whatever it is in a modern, fast, memory safe, strongly typed language. So people will kind of, I would say at times I've seen it overzealously attempt to rewrite things in Rust. But I don't think that all of that is quite as common as the meme would lead you to believe. In fact, I would say it's actually pretty rare that I have seen someone go after a project in a serious way about trying to have someone else rewrite something. I have seen people try to rewrite bits on their own and say, hey, is this a good replacement? Or try to replace it on their own. That I would say I'm perfectly okay with. But to go to someone else's project and demand that they spend their time rewriting in a language that they don't write in, I think that's just like, that's absolutely just being an ass.
Oh, yeah. Don't do that.
And that's the thing that the meme is mostly about, which is something, thankfully, I have not seen in my own perusing of the interwebs.
But the reason why that meme is a meme is because it's fun to rewrite it in Rust, not because it's necessarily a good idea, right? Like, it depends on the size of the program. And if there's a special case here, right? For people, I have seen people who've taken their old program and decided, I'm going to rewrite this entire thing in Rust. And if that's a one-person project, then they are the person best placed in the world to make that rewrite succeed, because they do know all those corners and things like that if they have sufficient knowledge of the old project, which of course might make them superhuman depending on the size of the project. But yeah, if you can fit the entire project in your head, then you're quite well placed to rewrite the whole thing, and maybe it won't be a complete disaster. And it might be fun, and you might be able to make the judgment that your ongoing maintenance from then on will be easier because of the advantages, for example, of the type system or whatever language you're using.
I think it also depends on what the source language is as well when we're talking about the meme of rewrite it in Rust. Although I have seen, different parts from any language get rewritten in Rust. The ones that the meme is mostly about from my optic is like C and C++ style. And I think that's mostly because, this is again my opinion, is that those categories of programs haven't yet had a language that meets all of those checkboxes of memory safe, extremely performant, low level, and strong type system. So there hasn't yet been a language that has kind of ticked all those boxes. There have been other languages that have made huge inroads, like Go, that do wonderful things when you can rewrite certain things, but Go doesn't handle certain classes of programs, which Rust still can handle at times. But again, I think I'll also be one of the first people to admit that there are times where Rust isn't the right language to write something in.
I guess the other aspect of this is the advantages to your users. So I have seen the other example that came to mind while you were talking about that, Kevin, is people who've rewritten Python tooling in Rust and seen a huge speed up from that. So if the advantage to your users is sufficient, it might be worth all that effort to do the rewrite. But of course, a tool that does something like code formatting or something like that is a much more limited size of project than some of the very large projects that I've worked on where a rewrite has, in my opinion, basically been a bad idea.
Are you talking about linters and stuff? Like I've heard Phelim talking about that on Late Night Linux, like massive, massive performance gains, like orders of magnitude.
Yeah, like 200 times faster.
Mm-hmm.
Being 200 times faster doesn't matter that much. Probably 10 times faster would have been good enough, right? But either way, it works.
Well, one of the cool things about those types of speed-ups is it allows new ways of using the program. So, for example, if we're talking about a linter or a code formatter or something, you can go from running that in CI to running that on every keystroke almost.
Yeah.
So it enables new ways of using the program, which then itself could also lead to other ways and other things that you can build on top of that due to the new performance.
Well, and also there's the environmental impacts. We've talked about this briefly before, but if you can make something 200 times more efficient, then that's got to be good for the planet long term, hasn't it?
Yeah, I mean, maybe there's a whole episode for us in talking about performance, because the other thing about performance is that it's incredibly addictive. And the reason why Git is so popular is because it performs so well.
I think it's also because humans are so bad at waiting. We're not very patient beings.
We've talked about feelings you should maybe ignore or push past to avoid rewriting, but what are some hallmarks that a rewrite might actually be necessary? Not concrete situations, but red flags, I guess.
Well, firstly, you're looking at the thing and it's not written in Rust, right? That's the first red flag.
I mean, that is now how I judge things, yeah. I think it depends what you mean. If you mean, when should I throw out the entire code base, write the whole thing from brand new, I think you're getting from me that the answer is almost never. You should always try and find a way of doing it more gradually than that. But I guess one red flag would be if it's in a technology that is just end of line, right? So if it's written in Visual Basic 6 and there's no way of moving forward from that, maybe it is the time to start. But that's maybe too easy an answer.
I think it also starts off with knowing what that pain point is that you're trying to address. So that could be something from, we don't have any developers in said language, or we can't hire any developers in said language, or we can only hire one. Maybe we have an abundance of programmers in another language and the whole team is familiar with something. Those are some kinds of things that you can look at. Other things could be, we have a ton of memory safety vulnerabilities in our code, and we're trying to address that in a memory safe language. Doesn't have to be Rust.
It's just that that's the best one.
And there can also be other reasons. Maybe performance is one of them. Maybe whatever language is written in right now, you're just not hitting the performance targets that you're trying to get, and you have to pick a different language that can hit those targets.
Actually, a great example of that is when Discord rewrote one of their backend components from Go to Rust. They were going so far as tweaking the Go compiler parameters to try and eke as much performance out of Go as they could. But then when they rewrote to Rust, even the simplest Rust rewrite gave them all of that extra performance for free, if I remember correctly.
So you're saying that Rust is better than Go then, Emily?
There's a time and a place for every language.
Okay.
Again, though, that was quite a smallish microservice, right?
Mm-hmm.
So I don't want to do it down. I'm sure it was a very clever bit of code, but it wasn't massive. So if you're talking about a smaller component, there definitely are going to be times when you need to do rewriting. And at that kind of time, what I would be looking for as a red flag would either be some of the stuff we've already talked about, like I can't deploy it for this customer, or that technology is not supported, or it doesn't perform well enough. If you're talking about smaller bits of code, then I'd be looking at things about code quality and is there a lot of code that would just go away if I did it in a different way? Or is there a lot of repetition that if I somehow approach the problem differently, I wouldn't need to repeat myself? Is there a lot of very fragile code that is very difficult to know if I change something here, will it break something over there? So if there's interconnectivity between things that are far apart from each other. Also, if it's very hard to test. Now, in almost all those cases, I would still say do it in a gradual, small, piece-by-piece way if you possibly can. But those would be good reasons to think about trying to replace code.
It seems like everything with you, Andy, comes back to, can we test it?
Yep.
Like relentlessly, which is fair enough. And also, can it be modular if possible? Like you want to just break it down into chunks and not have huge monoliths.
Absolutely. Yeah. It's always, for me, it's about, can I write just a function that doesn't depend on anything else, doesn't need anything else set up before I call that function? I can just pass the arguments into the function and then it does its work and returns me back the answer, and I can check the answer using a unit test. Then I'm happy.
You can have modular monoliths, though. That is entirely possible.
Yeah, and I think they're probably good. Like, if monolith means it's a big code base that compiles into one executable, what's wrong with that?
I don't remember exactly where I saw it, but there was one blog post that argued that modular monoliths are often a better choice than microservices because you're cutting out an entire failure mode of anything related to the network.
Yeah, and there's a lot of stuff going on in the network. Like, do you know how the DNS works within your data center?
Does anyone know how DNS works full stop?
Not me. What's your opinion on monoliths, Kevin?
Oh, I tend to agree with what you both said right there, that modular monoliths are the way to go. I'm not going to say that there's never a place for microservices because there obviously is places for it, but microservices bring in it's just so difficult to set up the environment and to deal with all the dependencies. I very much like what you said, Andy, how if you have the smallest unit that you can have, that you can test that particular unit in isolation, that makes that dependable and stable so that you can build on top of that building block with something else. And you can do this over and over and over again until you effectively, like Legos, right? You have the one little block that eventually turns into a giant castle somewhere. And that's made possible by breaking your code down into tiny modules and possibly shipping it as one giant castle monolith. But if you look at it up close, it's all a bunch of modules that can be individually tested and individually replaced if needed.
You know what that sounds like to me? It sounds like the Unix philosophy.
Do the one thing and do it well.
And connect loads of little parts together to form one bigger thing.
And have a standard way of them communicating. That's part of the Unix philosophy.
And there's also be broad in what you accept, but strict in what you output, or something like that.
How do we feel about that?
It's hard to do well, but I like the result.
So I have like individual examples of that within my code bases that I'm working on currently, where that can be both a good and a bad thing. So for example, in Rust specifically, if you are very broad in what you accept and you accept a generic parameter, you can also do things like blow up your code size. So there can be downsides to being super broad in what you accept. You can also make it harder to use your library ergonomically if you are too broad in what you accept because you're trying to be flexible for the user. Well, then the user might be looking through documentation, examples, whatever, and they see 4,000 different ways to call this thing. That might actually end up being more confusing in the long run. But again, that's a very niche little example. I would say be broad-ish in what you accept, and yeah, be very strict in what you output. That's a great part of it.
There must have been situations in your careers where you've come across a code base and it's just horrendous. It's just so bad that there's no fixing it. You've got to chuck it out. You've got to rewrite it.
I worked at a large company that's made out of 3 letters, and it had a very venerable, amazing, innovative email system. It's actually a system for building all kinds of applications, not just email. We were forced to use it as an email client when the company acquired us, and everyone hated it, which is normal. But I did talk to someone who had become senior in the group that looked after that application after they'd been working in our group before that. And I asked them, why does this system never change? And they said there is literally no one in the company who dares touch the code whatsoever. So the company had built a whole load of services around this thing. They built a new web-based email client that sat on top of this core, but there was no one who could touch that core code. And it was just this horrific, effectively just this binary blob of stuff that did its job and no one knew how. And in that situation, if you want to make forward progress, you've probably got to rewrite, I guess.
Presumably it was completely untestable, no comments, anything like that.
I never got a look at the code, but my understanding was it was an absolute nightmare. And so the only testing that you could do would be completely from the outside. No one knew how to work with the code. Now, that's not to say you can't do it, right? There's no code that's impossible to work with. If you hire people who are brave enough to do it and who understand the programming language well enough, you could absolutely get that code base back. But maybe at that point, with the amount of fear around it, it would be better to just throw it out.
Right, well, we better get out of here then. We'll be back in a couple of weeks. But until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.